Hey, hi. So let us look at what companies think AI look like and what actually is AI. So this is a very good diagram. So the companies, I mean, if you talk to your leaders who are not very tech savvy, they think that okay, you just have some data anywhere and you plug LLM models or AI uh, like Azure Copilot on top of it, and it works, and immediately you will get a value. So in reality, see, data will have a big chunk to play, a big role, because many people, when in December 2021, when AI, generative AI, ChatGPT, just released their first, it was the first release of ChatGPT. So people thought, okay, now a lot of things will change overnight, like within 6 months. I mean, the way leaders were boasting, it looked like okay, next 6 months, a lot of people should start losing their jobs. That was the first take. I mean, that was the first feel I was getting, and people were saying, "Hey, it's just moving so fast that uh, if you don't learn, then you would lose your job." That was the message coming in. So, so the next thing that we wanted to do understand is people told data engineers will have no role. Data is already there. You just have to plug AI anywhere and it works. Okay. But what is the reality? See, reality is data. You have to select the right data set, source it, you have to synthesize it. You got to explore it, like what sort of data you are putting. For example, you are doing a NLP, like a text to SQL conversions, so that you ask questions in English and it translates to a SQL query in the background and you get your answers. That will help you with your self-service BI. So it is a self-service kind of data that you, or a system that you have at your disposal to get answers. You don't have to rely on the IT teams. So then comes a portion of data engineering where you got to explore, you got to clean your data, you got to normalize it, you have to add features, you have to put scaling. That means the feature engineering. This is an important term. Feature engineering means, suppose you, it's in a simple term, I would say, uh, suppose you build some transformations or calculations in the ETL layer or the BI layer, that is feature engineering. You add a new calculation, and based on that calculation, you want to train your AI models. Okay, now with AI, on the AI piece, the modeling piece, what changes? First is training required with Gen AI? See, prompt tuning is required if you are just operating with prompt, but if you are trying to hit the first layer, uh, which gets exposed, so that you can train the model for something like ChatGPT or Bard or Llama, etc. You can tell them that, hey, you know what, this is my corporate enterprise data, this is it looks like. So you can train it on your data so that you don't get any ambiguous answers. It performs better than prompt tuning. So you got to do all of this exercise. And then value, from a value perspective, you have to deploy it. So for example, in the market there are different tools like Watson X dot governance, which helps you with deploying these models, doing a version controlling of the models. You don't have a CI/CD pipeline in this case to deploy the models. You have to use a separate set of products, and then you monitor it, whether is it drifting. A part of the monitoring involves what is the amount of drift. Does it drift every week? If it is drifting by, or the drift is crossing the threshold, you got to adjust it again. You got to either prompt tune it or you got to fine tune it. There's a difference between fine tuning and prompt tuning. Prompt tuning, you're just firing the prompts. Fine tuning, you're actually doing something to affect the first layer of the model. Okay. And then there are various constraints in the Gen AI world. There are a lot of constraints in the AI or Gen AI world. First is legal. A lot of time we think it is very easy, but then legally, are you exposing some set of data or some PII which you should not be exposing, like somebody's passport number, social security number, credit card information, uh, ethical transparency. You have to give a transparency. Hey, how did I arrive at these answers? I used these and these logics. There was a rack database in the background, and that is the data I used. So this kind of transparency you have to build. So that is a constraint, because every time I need to build a transparency, my trading cost goes very high. And then there is a historical bias. Okay, Virat Kohli, he performed well in the last five match, so he will most likely perform good in the next five matches. This is a historical bias. See, if you see currently India New Zealand series is going on, Virat Kohli is not playing good. But if you just see the pure statistics for the last 10 matches, you might think no, no, he should perform, and that is the reason selectors put him in the team in them. And then obviously there is security, so that firing different prompts, they should not get the IP IDs, the node address, so that they can get in and hack your data. So that should not be there. So these are the constraints. Why we say constraints? Because you have to be very cautious. The kind of innovation you want to do would get a bit constrained by these things like legal, ethical, historical security, and that is why the cost of training the models or fine tuning the models goes up. Okay, so this is a good concept. We discussed what companies think AI look like, what top leaders think, and then under the hood, what goes around to make these kind of AI work. And data engineering is a very important function in this case. See you in the next part.